Okay, so this is 9.5. We're finishing up the notes. And so for these problems, we finished this problem right here where we went through and found the tangent of this polar equation. So we found the equation, then we get a linear, a tangent line, a straight line. Is it not there? What you look for? The notes. I thought they were back there, but they still might be up here. That's fine. No one watches the videos anyway. After we've been in class 8 months, I finally have a couple of students subscribing to the videos now.
I don't know. Maybe. I thought I'm allowed to.
Are you grabbing it again?
No.
It's scary. Taking your phone.
No, it is. I'm leaving after this hour.
It's funny because I get alerts from people, or alerts on my YouTube when someone subscribes. So anyway.
Maybe we need a comment.
Okay, so in your guys' notes, I've actually added this also, so you can go through and actually graph some of these. Okay, table, go along. When we actually get certain values, okay, like this one right here with the inner loop. The inner loop right here is when my A is less than B, okay, I get a loop right here. Okay, that's important. So when I have A plus or minus B sine theta, so if the A is less than B, I get a loop. Over here, there's no loop when I have that B is less than A. Okay, that just goes along with the shape. Then for these next ones right here, we're going to have like a double angle or a triple angle or something like that. So it's going to give me how many loops I'm going to get in there. Okay. All right, so arc length of the graph of polar equation. So if a curve C is represented by a polar equation, R equals f of theta, and alpha is less than theta, which is less than beta, and if f prime of theta, which is the derivative, right, is equal to dr over d theta, continuous on an interval containing a and b, then the arc length of S, arc length is always denoted as an S, of C, which is whatever the function is, from theta is equal to, from alpha to theta is equal to beta. All right, basic. S equals alpha to beta, that's the bounds, square root of r squared, so my function squared, plus the derivative squared, okay, and d theta. All right, so when I'm doing this, I have to get the derivative, right? And I have to plug it into there. And then after I get all that in there, then I have to take the integration from alpha to beta of d theta. Did I say too much? Is everyone good?
No.
Okay, let's apply it. So if we apply it, it actually works a lot better. Find arc length of S of the logarithmic spiral, okay, by R is equal to f of theta, and which is equal to E to the 3 theta from 0 to 2. So let's see. So arc length, so formula S equals integration from 0 to 2, and I have the square root of
E to the 3 theta,
and that's going to be what?
squared.
Squared plus the derivative. So what would be the derivative? So if f of theta is e to the 3 theta. What is f prime of theta? There we go. 3
E to the 3.
e to the 3 theta. Okay. So that's gonna.
Square that.
Three.
Square that as well.
Okay, wait.
That was how I sounded.
There you go. Yes? Okay, good.
Yep.
All right, I'm gonna clear up my scratch work right here for my derivative, clean that up. All right, so let's see, we're gonna have integration 0 to 2, still square root of e to the 6 theta plus 9 e to the, and this is still d theta.
They should combine those.
Okay, so can I
10 e to the 6 theta.
10e, so integration 0 to, it's going to be 10e, so I'm going to do it like this. So it's going to be, no, it's still going to work, 10e to the 6 theta. Okay, so I could break that up, can I?
Square root of 10 times e to
Okay, so square root of 10 times e to the
3.
3 theta, yeah.
3 theta. Okay, so it's going to give me equals integration. So we're going to take out that. So it's going to be e to the 3 theta times square root of 10 d theta. And now what am I going to do?
Hold it, square root of 10 to the.
Yeah,
to the-
square root of 10 up front. Okay, now that I have that, let's go ahead and do the integration. Integration of e to the 3 theta.
1/3.
Yeah.
1/3. Okay, so it's going to be, let me see, I'm going to go rad 10, bracket, 1/3, e to the 3 theta from 0 to 2. Okay, top bound. That'd be e to the 6, right? Okay, so it would be, let's put it all together. So it's going to be rad 10 over 3 e to the 6 minus rad 10 over 3 times e to the 0.
30.
Okay, so we're gonna get some nasty answer, right? So, from this point right here, could you please approximate that for me?
$424.197.
424 point.
197.
Wow.
Wow.
Yeah, that's correct.
That's the arc length.
Yeah. Cool.
That's how long that arc is.
Do you guys agree?
Yeah.
Yeah, I concur.
That seems a lot.
Did we do something wrong? Wait, let's put the integration.
Because
That seems legit.
That's right.
That's from
Yeah,
Mega
that's right.
1.
Okay.
That's huge.
Okay. Yeah.
Let's see.
Are we okay?
Yeah.
So arc length is pretty basic.
Yeah.
Just what was the biggest issue out of all this? Probably setting up the formula, right?
Yes, yeah, this just, if it was harder to identify R and F of theta, or F prime theta.
Here we go.
Even then.
All right, so I'm going to give you the rest of this time. Get all that work in. We're going to be testing over chapter, what is this, chapter 9?
Yeah.
Chapter 9.